Okay, guys. Hello. I'm Jelle Gerbrandy. I work for Parati, and we're making a decentralized video platform. Just want to agree with Victor. Please interrupt me, and it's much nicer to discuss than to just listen to me. Okay. So I'm going to do two things. I'm going to explain to you very quickly what our project is about, and then I have some various remarks that I think may be relevant for the Swarm community from what we encountered.
Can you hold your mic closer?
Yes, I think I can. Okay, so the project is Parati. We're doing it, we have a team of about 8 to 10 people now, half of them in Brazil, half of them in Europe. There's one guy in Egypt. And so from, say, the PR kind of side, it looks like this. So what we are going to do, it's in Portuguese, but you'll get it. So decentralized video platform means the monetization is in your hands. It means there's no intermediaries, and there's even, it's the content that you want to see. This is probably not the part you want to be interested in, because you're probably more interested in the technology behind it, like I am. So in practice, so basically, so the project is, we would like to build a decentralized YouTube using the various tools and the various projects that are in the crypto and specifically in the Ethereum ecosystem. All right? And so in practice, what we need to build is something like this. So first of all, we have to build like the video pipeline, which basically means that we have to make we're building a system. What you do on YouTube, you upload a video. The video will need to be transcoded. Eric just explained perfectly what that means. It needs to be persistent, right? We need to store it somewhere. This is why I'm here. We need to make it discoverable, so we need to have this. We have a bunch of videos, and we need our users to be able to find them. So they need to be indexed somehow. And then we need to deliver them to the users in a fairly fast way, so they don't have to wait too much. And then we need a bunch of applications to actually view the video in a video player, a portal stuff. Okay, so that is like the basic infrastructure. We need to pay for this infrastructure, right? I mean, the whole point of one of the motors behind platforms like YouTube is that people can actually make money on advert in different ways. So once we have this, we are experimenting with ideas about how to monetize this stuff. We want to make an open platform where users can choose their way of monetization. And a third point, which is particularly relevant, not only now in this Facebook disaster time, but also because we're all building this on an open Ethereum system, the privacy anonymity issue becomes like a really difficult thing, because basically we have all our data in the open, and we need to hide them somehow. Okay, so we've been working on this for about a year now, and so of course we don't have this, right? I mean, it's enormous, this project. But what we do have is like a first version of this video pipeline. I will tell you what we have specifically later. And we have written this like generic library, which basically gives us a uniform interface to interact, which our applications can interact with the different pieces of the pipeline. And we do have a web player, and we have a portal. And we did a pilot with 20 uploaders. We have 250 videos. And this week, we should open it up a bit more. Okay. And well, you don't see it very well. So these are some screenshots of stuff we have. And specifically, this is one thing we like. We can tweet a video player. Okay, so I'm going a bit too fast now because I wanted to say something a bit more about this. So on the part of the, no, I will get to that later. I will, okay. So this is what it looks like now. So these are the basic steps of what we need to do with videos. So first they need to be transcoded, then we need to store them somewhere. We need to index them. They need to be curated in the sense that we need to organize the videos in playlists. We need to probably, if we put them on our branded portal, we need to censor them. We need to get rid of the child porn. And we have to deliver them to the users. And so this is what we have now, what we've built. Because the idea was we're going to build some stuff with whatever tools we can find and then try to decentralize all the pieces step by step. So for the transcoder, we just have our own transcoder, which is simple, but we are looking very much at LivePeer. We want to use LivePeer, and this would make this step decentralized. I've actually been working on integration. There's some differences in requirements because LivePeer is doing live streaming, which is, you can ask if you're interested. Okay, for the persistence layer, so these are basically two parts. So we need to store the videos themselves, and we need to store data about the videos, right? Whose is it? What's the title? Do they want to get paid for it? Stuff like that. And so what we're using is IPFS, and I will explain to you why we're not using Swarm in the next slide. So the videos are stored in IPFS, and the data is partly stored in, basically we store video records on Ethereum with a reference to a hash in IPFS where all the real data are. This is flexible, it works well. We would have liked to use Ethereum and Swarm. I'll get to that. For the indexing, so I think this is a real interesting point here. So you can store data on a blockchain, right? It's basically a database. But you cannot really search very well on the blockchain. And so what you need to do is index the data, right? You need to make a blockchain explorer type of thing. So I don't know of any, I mean, I know how to do this, of course. We can just put the database index stuff and do this, but I don't know of any decentralized solutions for that, any mature projects. And this is something, if you guys know of something, I would be very happy to learn about that. The curation part, so now we're basically not doing anything. We've done a pilot with people we know. But what we're actually working on now is to use TCRs, token curated registries for this. We are actually also coding there, but we're also very much thinking about what this would mean in practice in terms of UX. Also there, if you're interested, ask me and I will explain. And for the delivery, so for actually getting the videos to the users, we're using IPFS, and we were hoping to only use that, but we need a gateway because it's just not fast enough. And also there we would like to use Swarm. So why didn't we use Swarm? Okay, well, the basic reason is this. So one of our first requirements, or the first ideas was that, so basically this whole idea that systems like IPFS and Swarm are super scalable is because every time you add a node, you add bandwidth to the network, right? You make, okay. Given that we are looking at video, our nodes, most of our new nodes will be video players, people watching stuff in the browser, okay? And so for that idea to work, we have to instantiate a node in the browser, right? And so IPFS has a JavaScript implementation and has implemented the transport WebRTC transport layer. So with some tweaking, I mean, it was not immediate. We actually have now an IPFS node which runs in the browser. So this means that why this screenshot is so interesting, because here what we're actually doing is if you tweet one of our videos in our player and you open your Twitter feed in your browser, this will instantiate an IPFS node, which will both download and serve content. And I mean, this is really cool. This is one of the nicest things I've done in the last year. Okay, and so unfortunately, we could not use Swarm. Sorry, guys. And we would like to, which I'll explain to.
Maybe you could compile a WASM version of it this one.
I mean, there's also the WebRTC part. And yeah, so it's not so easy as just compiling the code, yes?
Why WebRTC, not HTTP and HLS? Isn't that more the generally used protocol?
No, well, because browsers are not HTTP servers. So they cannot, the browser, so that is.
That's only a client.
Yeah, so your browser needs to serve content to other browsers, and it cannot do it over HTTP. Because more questions, please. Listen to Victor. Okay. Cool.
So I mean,
Yes.
Okay. So I'm not as familiar with WebAssembler, but I assume that it can also interface with the WebRTC functionality of the browser if necessary, right?
Yes.
You need to write a transport layer. Right, so it's possible. You just have to.
Oh no, it's completely. I mean, we would have done it, right? If we had like infinite amount of money and people, we would have loved to actually build this stuff. Yeah. No, I'm not.
Just type it in a sentence. You can do it in a day.
Okay, so this diagram, I'm going to go over it very quickly. It's because it's more meant to illustrate how messy our stuff is going to be and how much better it could be. So basically, what happens in this stuff in this video pipeline is this: so we start here with somebody who is in a browser and wants to upload a video. And so what he does is he writes a record there to the Ethereum blockchain for the video. Part of it goes here in the persistence layer. And then he uploads a video to the transcoder. He tells the transcoder, please do this job. So here we would have like a live peer cloud, ideally. Then when the transcoder is done, it writes the resulting hash of the transcoded file to the blockchain again. And we have here the database index, which listens to events on the blockchain and makes a nice structured database for easy searching. Then, when there's a client who wants to watch the video, what it does is it asks here the database index. It searches for the video, for example, finds it, and then asks the persistence layer and the CDN network, let's say, for the video. And so given that, we've been trying to use the tools that seem to be most suitable for the job, and so what we ended up is with like this network where, which is messy and mostly on terms of, all these steps have to be done. That kind of messy we cannot avoid, but we are using different communication protocols and systems all over the place. So for example, here within the IPFS nodes, what we're basically using is an adapted version of the bit swap protocol. Because these nodes, these are all IPFS nodes, they are communicating anyway, so we added a little layer, some messaging on top for, saying I would like to transcode this job, or I've done, that kind of thing. Well, of course, the communication with the Ethereum node goes over HTTP and over WebSockets. The index, this is just HTTP stuff. And So what we find ourselves is getting this system which is getting more complex and complex, and I wrote it a little bit small, but I mean, the vision of the Web3 Ethereum stack, which combines the blockchain with Swarm as a storage layer and with the uniform communication protocol on top of it, is really very suitable for the kind of thing we want to make, right? If we had something like that available, it would make our life so much easier. Okay. So these were my generic slides, and then I have some specific remarks. So one of them is this. So I think this is a general. So we very specifically found that communication between browsers over WebRTC is very heavily throttled. If you start sending more data, then, I mean, we didn't do any systematic experiments, but it's like if you start consistently sending like more than 5 megabytes of data, which is very little, to the same peer, it will just start stopping it. I mean, we wouldn't work around that. I don't know.
Are you saying that ISPs are doing this? Or that
No,
the browsers?
this is Chrome. This particular WebRTC thing is Chrome. But what I want to say is that this is a more... I don't know. Yeah.
They are making huge improvements on the data channel in terms of less throttling, and I've streamed video through the data channel and it seems to work fine. So I'm wondering what the problem issue is.
So am I, yeah. So I have to explain also. So the person who should have given this talk is, I will go to the last slide so you can see him, this guy here. He's called Mohammed Yahya, but he cannot come here because he's living in Egypt. These are, like, he's doing the low-level peer-to-peer work, and he would have answered your question perfectly. But we live in a limited world. I mean, so we ran into this problem. I mean, it's just like shitty, okay, because you cannot control it. And I think this is I mean, the remark I want to make here is that this is, of course, part of a bigger generic problem, which, I mean, so this graph is, I think it's from like 2004, is about throttling BitTorrent by ISPs, right, in different countries. So yeah, I mean, the usual suspects, well, actually Japan, they're throttling like crazy. So, I mean, the point I want to make is that projects like ours, which is very specific about video, but Swarm in general, any kind of peer-to-peer, has to face this at a certain point, right? If we get browser makers or ISPs who somehow don't like all this peer-to-peer stuff, we can build all the cute technology we want, but we will be killed.
Yeah, I think that one potential sort of protection against this problem is that ISPs kind of have to support whatever becomes the more conventional way of doing things, right? I think they've been able to block torrenters, for example, because they're like a very small fraction of their user base. But if, say, 40% of the user base starts using peer-to-peer technologies for their general internet usage, I just don't think they're going to be able to really throttle that much. But there probably will be like this inflection point where before it goes mainstream, like they attack it, right? And then as it gets more and more common, they realize how we just have to go with it, you know?
But then it would be hard to get mainstream because it's
Yeah.
usually when they.
But there's always there's always a point of pain, right? Like, but yeah.
I mean, I think, I mean, yeah, I mean, if you have like a free functioning market, you would say, okay, if consumers want peer-to-peer stuff, they will get it from their ISPs, right?
Yeah.
But we don't have that kind of market. In a big part of the world, like, cite again my friend Mohammed Yahya is in Egypt, there's no question. that consumers can influence the behavior of ISPs. No, but also in the States. I mean, there are also very many other interests, right?
Yeah, I'm not saying that there's not resistance and there's not a challenge ahead, but I guess what I am saying is that, like, the more these technologies show promise and actually do something useful, then the more people start using it, the more we're going to get pressure behind, forcing people to start accepting and catering to these services, right?
Yes. Okay. Another generic point. This is more specific. I mean, I'm saying this because last year in Berlin at the Swarm conference, I've been asking, I don't remember whom of the Swarm team, are you going to implement? Are you going to implement Swarm in the browser? And they said no, because they're very shitty peers. And so I can confirm. They're really shitty peers. People watching a video, they will arrive, they will download stuff, and they will finish the video and go away, right? And we have this fact that they're in the browser. I mean, it's just like, it has lots of limitations for programming in the browser, and they're also all different, right? I just want to give some scientific feel to the thing. This is from an article by Flavio Ribera, who is one of our advisors. So he did an experiment where this was with WebTorrent, where it was an experiment with WebTorrent where people would see videos and try to download as much as possible from their peers instead of hitting a central server. And so the top graph here is the 100% is the hits to the centralized server if in the normal case where you don't have peer-to-peer connections. And this is what the reduction in hits to the central server when you added WebTorrent. And so in the best of cases, they got a reduction of 30-40%. I mean, this is not so bad, of course. I mean, it's really very good if your costs, if your job is paying for a CDN. But it's very long way off from our idea of using IPFS or something like Swarm as the single content distribution network. Okay. And
where the main bottleneck comes from for WebStorage? Why are they only able to offload 30% versus 90%?
well, no, I don't really know what the reasons are. I mean, but so I know. I mean, because they were using WebTorrent, I know it's well. I know, but IPFS, it takes a long time to set up the connection. I mean, that is, I think, the main reason. It takes a long time to set up the connection to find your data, and if you just hit, with a server, the data is there, and they can send it to you immediately. So I think it's the overhead. Yeah, I think so. Yes. I mean, with our stuff, what we see in IPFS is that the time goes there.
And do you mean the propagation time till the file is first available on the network, or in general request?
No, these are for the request for chunks of the file.
Okay, after they have been propagated already.
Yeah. So they're, yeah. Yes. Okay, this is what we could really use a decentralized trustless database index, whatever that means. Okay, thank you guys.